Jinsil Hwaryoung est une associée de professeure du département de visualisation du collège d'architecture et de faculté du centre de Texas Université. En fait, c'est une artiste. Elle travaille dans le domaine de l'humanité, de l'art et aussi de la recherche et de l'enseignement. Donc, elle va nous montrer comment les applications de réalité virtuelle peuvent être intéressantes en anatomie. Elle va nous expliquer ce que c'est qu'une approche constructiviste. Et je vous répète, donc c'est une artiste et son domaine, c'est le domaine de l'architecture, de l'art, et donc elle a un esprit très ouvert. Thank you very much. You can talk now. Yes, thank you.
All right, thanks. Do you see my slides?
Yes. Yes.
Okay, that's great. Thank you.
We hear you. We go. We can hear you.
Okay, thanks. Hi, my name is Jinsil Hwaryoung Seo from Texas A&M University. Today I will talk about towards constructivist approach using virtual reality in anatomy education. Today I'm going to talk mostly about the projects we've been done in this line. Hopefully, whole series of works help everybody understand what we've been trying. So whole journey of our research was started from this one bone box. So I'm also the instructor in the arts department as well. So I teach sculpture. And then one of the students, actually, she was minoring in art, and then she was carrying this bone box around. She was majoring in biomedical science. So I asked her, what is this? And then she showed me everything, like all the bones inside of the box. It was like, the bones from a dog. So when I saw it, I was like, oh my God, so many bones. And, how do you memorize and learn everything? And then she said, like, it's really difficult. So I started kind of like thinking about how we can incorporate, immersive technology and interactive technology, to support students learning anatomy. So since then, I've been collaborating with, faculty in vet school and medical school, like really looking at how students learn anatomy and what are challenges and what are current materials and then what we can do for them. So current materials still in undergrad level, they use like textbook diagrams and models and flashcard, and a lot of students actually create their own flashcards and dissection, of course, and they use bone box as well. And then there are many issues and challenges in anatomy education. Students feel really overwhelmed, and because it's a lot of information, and also the English, the terms are Latin or Greek terms, right? So it's difficult for students in the States. And then also they learn from mostly static images and aesthetic models, but the reality is all dynamic and interactive. And then also students has actually some disability. I don't know it's disability, but they feel weak in understanding spatial concept of the body. Dissection is known as the most effective anatomy education method, but dissection-only approach offers a subtractive and deconstructive perspective. So, like people can start from the outer skin and then going into the bones, but in the end, they don't really see the structure, right? So we really wanted to help them, like, they understand, subtractive method at the same time, additive method. So we started from these related educational theories, constructivist learning and constructionist learning. Basically, like people learn better through making and creating and, manipulating things. So there are many strategies in active learning, including writing, role-playing, hands-on technology, artistic practices, and so on. So we applied that concept through embodied learning in anatomy education. So our focus been embodied learning in immersive environments, focusing on active creation, direct manipulation, and kinesthetic learning and collaborative learning. I'd like to introduce some foundational activity even before go into virtual reality or augmented reality. So we created an honors class in gross anatomy. We introduced some artistic practices, so it's not just, destructive, method. They were able to draw and then sculpt and then paint and then, learn anatomy through their movement. So the first exercise was drawing, students really focusing on the detailed drawing and then learn parts and then learn about the, the names of each part. Of course, they expanded, this drawing and painting activity through body. So they painted, the inner parts of their body on their own and then, partner's body. So through this, students really liked this. And as first we introduced this method, we were kind of worried because these are all science students, medical science students, they may not like all these artistic practices, but it turned out it really helped them to understand, really visual feedback, physical visual, but also, hands-on activity really helped them to understand and learn. And then that information they learned through this activity actually stay better, last longer on their mind. We also introduced clay sculpting skills. This is me, sculpted body parts, limbs, different limbs in human body and the canine. So we introduced this sculpting, like clay sculpting through anatomy in clay product. Students sculpted different parts, body parts and muscles, and then learn where it starts or where it ends, origin and insertion. So they were able to see the structure, but also the relationship between muscles. The next one is we actually brought anatomy students to dance studio. So they actually touch each part, their partner's body and then make movement and then see how each muscle really react, to different movements. And also, we kind of let them feel how does that feel? When you move certain muscle and when you posture certain things, certain posture, then what's your feeling? So we kind of have them to feel how other people, how other organism, feel about certain movement and certain damage on their body. So based on that, those practical and artistic based method, we started incorporating some digital and immersive technologies. The first one was AR technology. That was about 2012 and 13. So at that time, virtual reality technology wasn't really there yet. So we tried incorporating AR technology through tablets and also simple head-mounted display for AR. So we created, 3D printed bones with certain markers, and then it gives, the information of each part's names, and also it shows, how each part works or something like that. And then the last one, we created an AR application that detects specific terms, parts of the anatomy. So it shows a 3D model of it right away. So they can see details, they can move things around. So I'd like to talk now about Anatomy Builder VR. This was our first virtual reality application. As I said, this was started from the real, scenario, real story from my students. And she's been carrying this bone box. And then one of her challenge was, okay, I like these bone box because I can see all the details, but I cannot really make a structure because, I have only 2 hands, I cannot hold more than 2 bones, or maybe if I hold really hard, then I may hold 3 bones, but no more than that, right? So in this VR application, we, allows users to conduct construct 3D structure, something like this. So it has anti-gravity room, so they can actually build the 3D structure using bones. So Anatomy Builder VR is a comparative anatomy learning application that examines how virtual reality system can support spatial visualization through embodied learning method. So the backbone of the project is to pursue an alternative constructionist pedagogical model for learning canine anatomy. And then also we have a human version as well. So in this application, they were able to put them together and also draw muscles between bones, and then activate it and then kind of like simulate how muscle actually creates certain movements. Let me show you a little bit of parts of the application here. So it has a little bit of lecture slides.
To study anatomy, you first need a way to refer to these structures relative to one another.
So in this structure, they can assemble, and then they compare the lesson next to the structure. Then provide some details. And then here, they can actually assemble the 3D structure. So they can, students can see details of each bones, but also they can see how they get together, put together, and then they can actually guess, this is gonna be the functional, structure or not. Okay, we have human version and also canine version. So one thing, we call this environment a sandbox. You see like some things put wrong, it's more like a play. But I think the reason why we had this sandbox room was the anatomy instructors really wanted to have some space, people to explore by themselves and then find out, oh, this is not correct, like it's not gonna work. Because cadaver dissection, gross anatomy lab, like they cannot make mistakes, right? There is only one way to dissect and one way to see materials. But here they can put structures, oh, this is not correct, and they can actually fix it. Okay, next project, Muscle Action VR. This is an embodied learning VR that allows students to explore effects that muscles have on their body. So there are many applications kind of like simulates muscle movements, but still it's kind of hard to, relate that information to the actual patient or themselves. So this application we created, students can, students becomes a muscle man inside of virtual reality. So with the, HTC Vive goggle and then controllers, that user becomes this muscle man within the virtual environment. We have only muscle men, not women at this point. And then, how they move, that immediately simulates in front of them. So they can relate, certain movements they make, how that creates certain muscle movements, groups of muscle movements. And then they can see their side and back and, different perspective, just changing the camera view instead of they turn in front of, turn it around in front of the muscle. In front of the mirror. And also they can isolate certain areas of muscles they can focus on, and also they can see entire body muscles as well. So this one, it shows, okay, do this movement, and then you will see how your body actually reacts. So it's kind of hard to see, but this area, it has kind of the muscle color is, more red. So it shows which muscle is activating with specific action. Next project I'd like to introduce is Innervate VR. It was created to expand an existing anatomy education platform by implementing a more dynamic and interactive user interface, focusing on innovation. So here, as an artist and like a developer, it was quite difficult, to understand all the details of the whole body movement. So my students created, the animated, like structure, and then the, anatomists, from vet school and medical school, like they couldn't quite understand, because, like, okay, muscles don't move by themselves, like they have to have, like nerves connected, otherwise they cannot make movements. So we, like tackle that part. So as you see here, students, like simulate what's a healthy movement from, this structure. This is actually canine thoracic limb, I believe. So it shows, healthy movements, moving like that. And then the students in the virtual reality environment, they can actually damage certain part of the nerves connected to the muscles. And then simulated, like damaged movement. So if certain part of the, nerve got damaged, it cannot create healthy movement. So you can compare the movement on the left and on the right, they're different. And then again, this is a video. So as you see, there are two structures. This one is healthy leg, and then the middle of the middle one is, the experimental leg. So the students can damage certain part and then simulate. And also students see the depths with changing muscle opacity. So the students will damage certain area of the nerves, and then it highlights certain muscles, damaged, affected by that damage. And then you can see in real time, like what are difference between healthy leg and damaged leg. So in this environment, it's not just the simulation of the movement, but students also can walk around and then see the structure and the simulation from different perspective. We have a human part as well. Currently, it's more like simulation based. We're working on making it more interactive at this point. So next one, this is not so much about just anatomy itself, but I'd like to introduce, recently we incorporated haptic gloves into this education, actually this one for nursing education, but it has also anatomical components, so I'd like to introduce. So again, all this, embodied learning and physical movement and creation, and how they really feel certain things within virtual reality environment, we focus on, incorporating haptic device. And then this device is really early stage at this point, so it looks not so good, but let me show you. Think about here. So this haptic gloves on the right corner, it's pretty bulky and heavy, and then this shows the fetus inside of woman's like pregnant woman's belly. So the students can see. Sorry, just stopped. Students can see and feel, and then how that, their touch really makes any impact on fetus. So this is a Leopold's maneuvers process. Students learn, like this
through this process, students can learn the size of the fetus and, the weight of the fetus, and then the position of the fetus or something like that. And then with the virtual reality, it's almost impossible to feel anything. So we incorporated, a haptic device into it. And hopefully we incorporate haptic device into the anatomy education. So when they touch certain part of the body, muscles, and then, what does it mean? So as students, went to the dance studio, they feel other, their partner's body, and then feel the muscle movements, muscle change, right? And then they can feel that within virtual reality environment. So today, I talk about, different applications. We focus on constructionist method, exploring active creation, manipulation, and kinesthetic learning. Collaborative learning, I didn't show any examples, but it's currently working on multiple students being part of the VR. At the same time, they communicate, they do together and simulate together and learn together. This collaboration, these works, couldn't be done without these collaborators from these parts in our university. Thank you so much. If you have any questions, feel free to contact me later.
Thank you, Jinsil, for the very interesting approach and constructivist approach, which is interesting for us to teach anatomy, not only dissection, but also to make a construction, create something very, very important. We will have questions for you in a couple of minutes. We finished with the last speaker.